This is our lesson for Chapter 4, Lesson 1, Designing Studies. So the big idea I'd like you to keep in mind here is how can we conduct studies, surveys, and experiments in a manner that produces reliable and unbiased data so that we can accurately answer a question about a population. Now, one suggestion that I have is to go to the Schoology, pause this and go to the Schoology page where the vocab's posted. This outline's also posted. This chapter is very heavy on vocabulary and how to design things, and there's far less math. So I'd be looking at the vocab. I'd print that out to have a copy of it ready to go. So the first key idea is the population. Population is the overall group that we're interested in of individuals, and the sample would just be the part of the population that we actually collect data from to draw conclusions about the entire population. Now, the key things to think about are how we gather that sample and what we do with that sample once we have it in order to remove bias, or meaning trying to be objective here, trying to find what's really going on without throwing some kind of bias on our data. So let's look at an example of population and sample. So for your Chapter 4 project, you're going to be looking at creating your own data. You're investigating all students at SHC, so that'd be your population of a survey experiment that you'll conduct. The students that you randomly choose from a list will be the sample. They're the ones you actually gather data from, and you're going to do so in a representative way so that the sample you get should represent the true population. So a population could be people, in the case of your project. It could be animals or things, depending on what we're investigating. It's not always people. So it's important to differentiate between population and sample. Now, the reason we have a sample is because it's usually too costly and time-consuming to gather information from the entire population. So we want to gather a small piece of information that could give us a picture of what's really going on, or it should give us a picture of what's really going on. So things you want to look at is the type of investigation. Is it a study or a survey? Is it an experiment? And how well is it designed so that we can apply what we know about the sample to the population? So a sample survey, you'd state the population you want to investigate, you'd state what you want to measure, what the variable is you want to measure. So our population could be all Americans registered to vote, and we might be interested in the percentage supporting a particular candidate. And then decide how to choose the sample from the population. We try to avoid bias by finding a representative sample. We want to avoid convenience samples and voluntary response samples. Convenience samples are ones that are just taken conveniently, like standing in one place and just talking to the 10 people that come by that one place, which could obviously lead to bias, as people that aren't in that one place don't get to answer, or people who aren't at that place at that time don't get to answer. Voluntary response can also lead to bias, since you don't have to respond, like phone calls or emails with surveys. People don't have to respond. So if they don't respond back and you only get the volunteers who send it back, then you're getting a skewed sample as well. Maybe you're just getting the super overachievers that are responding, and you're not getting people who are more absent-minded, and that could skew your results. You could also not be getting people who don't answer the phone. Maybe they just don't answer the phone because they're not home or not home as often. So all kinds of bias that could be led to from a convenience or voluntary response. So when asked to describe how a study leads to bias, you want to identify the direction of the bias. That means how this design will affect the results. Will, as a result of your convenience sample or your voluntary response sample or whatever poor sampling method you use, how will it influence the direction of your bias? If you're sending out a survey on the amount of money spent on electronics in the last year, and you email it out to a list of people, people who don't have email would not be able to respond. So people who do have email, you'd expect a higher estimate, because if they're buying electronics, they obviously have a computer to check the email on. So that's just an example of bias. So you want to say the direction of the bias, whether you'd expect an overestimate or an underestimate. So write-in and call-in polls are almost always going to lead to bias. Use a strategy that doesn't involve bias. Now this is key, and we're going to be discussing it all year. Random sampling. Truly random is key here. So SRS, we'll call it, a simple random sample. And this is how we can generate. Now when asked on a test, a nice way to describe an SRS, where you don't have to worry about getting caught up in details, is this first one: placing the names in a hat of all the people you're choosing from. a whole population, shuffling them up and drawing the sample without looking. That's random. We're randomizing it, we're grabbing at random. We could also use technology to generate one. So math, if you go to the math button and probability, you go to number 5, randint. If you did randint 1, 28, it generates a random number between 1 and 28, inclusive, meaning including 1 and 28. So that could also generate an SRS. Now, something you'll run into there is numbers could repeat. So if I did randint 128 2 times, I could get 26 twice in a row. Now, if we're randomly sampling, we would have to describe how we skip repeats like that, because we're not going to ask somebody the same question twice. That would not be representative. A third option is using a random line from table D. So pause, open the back of your book, look at table D, and look at picking an SRS on page 212 to 213 using table D. So table D is a random digits line. We're going to go over in class how to do this a little bit, but get familiar with the example on 212 to 213. So if you have questions, you can come with them to class. So problems we run into with an SRS is because with large populations, it'd be hard to obtain an accurate list of the entire population. You'd have to assign this large population numbers in a list and then generate numbers to pick from. For example, I'll be asking Ms. Nerney for the list of all students at Sacred Heart so that you can conduct your survey or your study. Perhaps I'll just ask for a list of juniors and seniors, since most of you guys are juniors and seniors, and that's the population we'll most likely be investigating. So if we investigate with replacement, that means that once a number is drawn, you could put it back in the population, you could draw it again. So with replacement would be like if they were doing lotto and they got the ball that's 10 came up, and then they put it back in and you could get it again. Without replacement is what we use most often, which means that once a number is drawn, it's placed back and can't be drawn again in the same SRS, the same simple random sample. So this is important to note whether you're going to want to use with replacement or without replacement. For your investigation on the Chapter 4 project, you're going to be doing it without replacement because you're not going to want to. We don't want to ask people the same question twice. That would make our sample it would likely make our sample less representative of the true population. Let's take a look at some different strategies for choosing an SRS. A stratified random sample would break a population into groups based on a strata, or another definition of that would be a common characteristic, and then take an SRS from each group. So if you think members of a group are similar to each other in some way that affects the variable being measured, for example, if you think your gender is going to affect the answer to a question, you could break them up into male and female groups and take an SRS of 30 from each group. So you choose the strata based on facts known before the sample is taken. Like my question is regarding how many pairs of shoes you have. For example, we've seen that in my experience that women tend to have more shoes. So maybe if I wanted to get good, accurate data, I would separate the groups into male and female and then choose an SRS from each of the equal number from each. And then I could compare males to females. I could also get a better idea of what's truly representative. A radio station could break up the population into regions based in the country, because maybe the local culture is likely to affect whether individuals like a song. For example, in Texas, there might be more country music that's favored. A radio station could also break up the country into regions, as the people on the West Coast may be more likely to like music from the West Coast than the East Coast. Like maybe people like local music as well. So the radio station features more local music. And when they sample by geographic region. That would be the strata or characteristic they would be using to take a stratified random sample. A cluster sample would divide the population into smaller groups in which each group mirrors the characteristics of the population. So each group or cluster would be have a similar breakdown of the characteristics of the whole population. So if 50% of my population is female and 50% is male, then each one of my subgroups would have 50% male, 50% female. There could be any number of characteristics, race, income, depending on what our question of interest is, that would be determined by that. So you would then choose an SRS of the clusters. So meaning you would number the groups, like let's say we had 10 groups. Each one of their relevant characteristics reflects the true population. And then we would number the groups 1 through 10, take an SRS, maybe we want 2 of the groups, so I'd get groups 2 and 4, and I would take the entire group and ask them a question. So this happens on airline flights. Rather than taking an SRS of every flight and asking the 10th and 25th and 32nd passenger, they'll sometimes just take an SRS of the flights and then ask everybody on that flight to fill out a survey. So that way, their thinking is that each plane flight should be representative of the true population of people who buy tickets to fly with them. Administrators wanting feedback from seniors on the use of Schoology could decide to use homerooms as clusters to generate their sample. One would hope that each of the homerooms would truly reflect the breakdown present in the senior class then. So they could choose 5 homerooms and ask everyone in the homeroom as opposed to asking every single senior. So these are all strategies to try to be objective when conducting a survey, study, or experiment so that we can use the results of our sample to infer accurate information about the population. Ultimately, we want to know what's going on with the real population, and that's why we want to have a sample that represents that population. So our goal is to have a reliable sampling method and way of administering our survey or experiment so that we can use our results to infer accurate information about the population. So we try to be as objective as possible. Convenience samples and voluntary response samples would be misleading since the sample wouldn't represent the population. And just by chance variation, when we have random samples, we're not going to get the same as they are for the entire population. So by chance, we might choose more females than males. By chance, we might have another lurking variable that's affecting our results. And then later we're going to investigate how the rules of probability allow us to determine a margin of error, meaning an interval that we're confident that we actually have the true value. So it's like when you see 48% of Americans support President Obama plus or minus 3%. So the margin of error is plus or minus 3%. That means they're sure that the true value is in that case would be within 45 to 51%. We'll go into how to calculate that later in the year. Large random samples will give better information about the population than small samples, since due to chance variation, we're more likely to have a truly representative sample, because by chance, choosing a lot of people will get a better result, more similar to the population. We're more likely to get a representative sample. So a minimum of 30, make sure that we're likely to have a representative sample, and it'll allow us to do a lot of the calculations we'll go through later on in the year. Pause right now, take a look at page 220 in your book for an example activity, and then come back. So sample survey problems, other than sampling variability, when we try to conduct studies, surveys, and experiments, we get errors that occur like undercoverage. Some groups are left out of the process of choosing the sample. Non-response. Individuals chosen cannot be contacted. That's different than voluntary response. So if you choose somebody, you just can't get in touch with them. And then response bias, when the wording of a question creates bias. Now, response bias is going to be key for your project. You're going to be doing something on your topic and wording a question in 2 different ways. One of the options is to word a question in 2 different ways and see if it creates bias in your results. So see if you can skew the results based on the wording of a question. That's one option. Okay, so right now is a good time to read over this multiple choice question and then pause, read through Chapter 4, Lesson 1, and look at the examples, and look through Table D in the back of your book, as well as look through the summary and of Chapter 4, Lesson 1, and the examples in Chapter 4, Lesson 1. So here's your multiple choice question. Pause here, and then click on the button below to answer the multiple choice and the free response for this lesson. Also, keep in mind vocab is on the Schoology webpage, and so is the outline. So this is about SHC students who want to know how much time students spend on homework, and 2 strategies they have. Are these biased or unbiased? And if they're biased, how are they biased?